Hello dear students, this is the third lesson for functions. In today's class, we will solve some miscellaneous question which will test our concepts. Question number 1, f and the function f and g are defined by f of x is 2x, g of x is equal to x square. And we have to find number 1, f of g of x. F of g of x. We know that f of x is 2x and g of x is equal to x square. So what is the method for finding f of g of x? This is basically f of g of x, that is in f of x we will replace x by g of x. So that will be 2g of x, and in the second step we will put the values of g of x, which gives us 2x square. So this is the answer to the first part. In the next part, we will find g of f of x. Okay, g of x is equal to x square. So g of f of x will be f of x square. And f of x is equal to, if we see f of x is equal to 2x, so this is equal to square of 2x, which will be 4x square. This is g of f of x. Next, we have to find f square of x. In the last lesson, we discussed what do we mean by f square of x. By f square of x, we mean f of x, which is f of x, which is f of 2x, which is 2 times 2x, which will be 4x. Similarly, now we are going to find g square of x. G square of x is equal to g of x. G of x is equal to x square. So this will be g of x square, which will be x square's square, ultimately x power 4. So this was the fourth part. This was our first question. We were asked to find f of g of x, g of f of x, f of x, also called f square of x, and g of x, also called g square of x. Moving to our next question now. F of x is given. We have to find f inverse of x. There are four parts actually, and in all these parts we have to find f inverse. We are just recalling the lesson number 1. F of x is given. What is the procedure for finding f inverse? F of x is equal to 2x plus 1. We will replace f of x by y. This is our first step. Then in the second step, we will solve this equation for x, and we will find value of x in terms of y. In the next step, we will replace this x by f inverse of y, and in the last step, y will be replaced by x. So this is the inverse of this function. Let us solve part 2. Excuse me. Y is equal to 1 minus 3x. Solving for x is equal to 1 minus y over 3. F inverse of y is equal to 1 minus y over 3. F inverse of x is equal to 1 minus x over 3. I hope it is clear. Third part, f of x is equal to x square plus 1, y is equal to x square plus 1, x square is equal to y minus 1, x is equal to y minus 1 square root. y f inverse of y is equal to y minus 1 square root f inverse of x is equal to x minus 1 square root. If we put x is equal to 3 over here, we will get y 9, and if we put y is equal to x is equal to 9 over here, we will get y is equal to. So the last part of this question, what is the first step? F of x will be replaced by y. Next step, we will solve this for x. Y into 2 minus x is equal to 4. 2y minus xy is equal to 4. 2y minus 4 is equal to xy. X is equal to 2y minus 4 over y. And next, we will replace x by f inverse of y. 2y minus 4 over y, and then y will be replaced by x. 2x minus 4 over x. This is the inverse of this function. Now we are going toward the third question of today's lesson. Dear student, this is very important. Find the ranges of the following function, part 1. So we are going back to our lesson number 1 of functions. F of x is given. We will first of all have to convert it into standard form. X square minus 16x plus 8 square minus 8 square. 8 is half of coefficient of x. Its square will be added and subtracted. First 3 terms will complete the square, and next is 64. So remember our lesson, any function of the form f is equal to a times x plus b whole square plus k, f of x is greater than equal to k will be its range if this a is positive, and f of x is less than equal to k will be its range if this a is negative. In this case, a is 1 positive over here, so its range is f of x is greater than equal to minus 64. Its second part, again a quadratic function is given. F of x is equal to 2x square minus 12x plus 19. To bring it into standard form, we will take out 2 from the first 2 terms, and now square will be completed within the brackets. X square minus 6x plus 9 minus 9 plus 19. This will be 2 times x minus 3 whole square minus 18 plus 19, and this is equal to 2 times x minus 3 whole square plus 1. So f of x is less than equal to 1, sorry, greater than equal to 1 will be its range, because a is again positive over here. Its third part, f of x is equal to 4x minus x square. Now coefficient of x square is negative. I will take negative 1 common. This is x square minus 4x. This will be negative of x square minus 4x plus 4 minus 4. This is equal to negative of x minus 2 whole square and plus 4. Coefficient of x minus 2 square is negative, so its range will be f of x is less than equal to k, and k is 4 over here. F of x is less than equal to 4 is the range of this function. Next part of the question, f of x is equal to 7 minus 8x minus 2x square. Dear student, here again coefficient of x square is negative, so what will I do? I will take out minus 2 common from the last 2 terms. First term is written at the end. Now I will complete the square within the bracket. This will be negative 2 times. These three terms is square of x plus 2. Minus 4 and minus 2 will be multiplied to plus 8. And minus 2 times x plus 2 whole square plus 15. Again, the coefficient of x square is negative. Its range will be f of x is less than equal to k. K is 15 over here. F of x is less than equal to 15. This was the fourth part of this question. Last part of the question. Now, f of x is equal to 25x square plus 40x plus 4. You see, this 25 is square of a number, so I will write it 5x whole square plus 5x into 8 plus 4. Now half of this is 4. I will add and subtract the square of 4 plus 40x plus square of half of 8 is 4, 16 minus 16 plus 4. First three terms will complete the square of 5x plus 4 and minus 16 plus 5 is minus 12. So coefficient of x square is positive. F of x is greater than equal to k, or f of x is greater than equal to minus 12 is range of this quadratic polynomial. So in this question we discussed about range of the quadratic polynomial. Very important. It will be very beneficial when we will move to our past year exam questions. Now, question number 4. In each of the following part, f of x is given. We have to find the least value of k for which function has an inverse, or f is 1, 1. We know that function will have its inverse if it is 1, 1 function. This concept will be understood with the help of graph as well. So what we have to do, first of all, we will have to convert each and every part of this question into standard form. I am doing it rapidly. Minus 4x plus 4 minus 4 plus 2. This is equal to x minus 2 whole square minus 2. So its graph will be like this. It will have its maximum value at x is minimum value at x is equal to 2, and that will be minus 2. This is the vertex. Coefficient of x square is positive, it will be opening up. X coordinate of vertex is 2. X is equal to 2. Before x is equal to 2, function is 1, 1, and its inverse will be existent. And after x is equal to 2, it will be 1, 1. Its graph will exist. Now, this function was defined for x greater than equal to k. This k is basically 2 over here. So, after 2, the function will be 1, 1. So, the x coordinate of vertex is the critical value of k. If this x is greater than equal to k, then we say least value of k is 2. If it was x is less than equal to k, which we will see in later questions, then we could not find the least value of k, but we could find the greatest value of k for which function is 1, 1. This was part 1. It means that in every such question, we have to convert the quadratic polynomial into standard form and look for its x component. That will be either the least value of k, or it will be the maximum value of k. If x is greater than equal to k, this will be least value of k, and if x is less than equal to k, this will be the greatest possible value of k. So over here, f of x is equal to x square plus 6x minus 8, and I am completing the square. X plus 3 whole square minus 17. X is equal to minus 3. So x is greater than equal to minus 3. Least value of k, minus 3. Again, same question. I will just convert every such question into standard form, which we learned in not only in O levels but also in the first lesson of functions over here. So this will be putting x plus 1 is equal to 0, we get the least value of k. Now this question number 5 is basically very similar to this, but in these questions the function is defined by giving the greatest possible value of x, which is k, and we have to find k over here. Solution is the same. We just have to convert all these quadratic polynomials into standard form and put the x coordinate of the vertex equal to k. F of x is equal to x square minus 4x plus 2. When I will convert it into complete square, I will get x minus 2 whole square minus 2. X is equal to 2. So the greatest possible value of x or k is 2. Same question. F of x is equal to 2 times x square minus 2x plus 5. I will just complete the square. X square minus 2x plus 1 minus 1. 2 times x minus 1 whole square plus 3. X is equal to 1 is greatest possible value of k. I am leaving the part 3 for you to solve. Try to solve this question at home. Dear students, in this lesson, we solved some miscellaneous questions to get ourselves ready to attempt past year exams questions from this topic. In next lesson, inshallah, we will solve some further miscellaneous questions. Until then, Allah Hafiz.